Relate the gas pressure produced to the mass of reactant on the calibration graph. Find 0.095 atmospheres on the vertical axis, pressure of gas produced, of the calibration graph. Moving horizontally to the calibration line and then vertically down to the horizontal axis, mass of CaCO3 yields a corresponding reacting mass of approximately 0.20 grams of pure calcium carbonate, CaCO3. Calculate the moles of reacted calcium carbonate. The molar mass of CaCO3 is approximately 100 grams per mole. Convert the mass from step 1 into moles. N, using the formula N equals m over m, moles of CaCO3 is equal to 0.20 grams over 100. Grams per mole equals 0.0020 moles of CaCO3. Apply reaction stoichiometry to find the minimum moles of hydrochloric acid, HCl, needed from the balanced net ionic equation representing the reaction of solid calcium carbonate with hydrochloric acid. 2H to the power plus CaCO3 gives Ca to the power 2 plus H2O plus CO. 2. This chemical equation shows a 2-to-1 stoichiometric ratio between H to the power plus ions from the strong acid HCl and CaCO3. Therefore, reacting 0.0020 moles of calcium carbonate completely requires exactly twice as many moles of acid. Moles of HCl needed equals 0.0020 moles CaCO. 3 times 2 moles HCl over 1 moles CaCO3 is equal to 0.0040 moles of HCl. Calculate the minimum molar concentration, molarity, of the HCl solution. The sample of eggshell reacts completely with exactly 4.0 milliliters of the acid solution. Convert this volume to liters. 4.0 milliliters equals 0.0040 liters, and solve for molarity. M equals moles over liters. Molarity of HCl equals 0.0040 moles of HCl over 0.0040 liters of solution equals 1.0 molar. This confirms that the concentration of the hydrochloric acid solution was at least 1.0 molar, identifying option D as the correct answer. The correct answer is option D, 1.0 molar.